Hello and welcome to the second product demo for the SWENG 894 Capstone project. My name is Chris Bassani and today I will be presenting the final state of Crypt after sprints 3 and 4. Crypt is a 2D top-down action roguelike built in Unity. The player controls the knight through randomized dungeon rooms, fights enemies, collects item rewards, opens locked chests, navigates trap rooms, and completes final wave encounters. The concept has stayed consistent since the first demo, but the implementation has become much more complete. At Demo 1, the project showed the core foundation: starting a run, moving, attacking, basic dungeon rooms, and early item behavior. For Demo 2, the application now represents a complete vertical slice. It includes the whole gameplay loop and several stretch systems, such as expanded item effects, custom seeded runs, a second hard mode floor, and dungeon maps. The system is intended for players who enjoy action roguelikes and dark fantasy games. The value comes from combining procedural generation, combat, item progression, and room-based exploration into a compact but expandable prototype. This is now what a conceptual run looks like when playing Crypt. It hasn't changed much since the first demo, but there are a few different things that have been added and its stretch goals to enhance the full run experience and how it plays out. A run begins at the main menu, where the player now has the option to use a random seed or enter a custom seed. That seed is used to create the first dungeon floor. The floor uses a 4x4 grid with connected rooms that include starter rooms, enemy rooms, trap rooms, and a final room. When you first start a run, you will see a mini-map with the grid laid out in the top right corner that displays information about the rooms you have uncovered. The main loop is repeated across rooms: traverse, fight, collect items, open chests, and avoid traps until you reach the final room and feel confident enough to face the final waves. The biggest progression change from the first demo is that clearing the first final room no longer immediately ends the run. Instead, it opens a portal to a second mode floor that continues the same gameplay loop with more dangerous enemies. The player keeps items and stats and heals to full health when they arrive. Completing the second final run is how you can win the game run. If your health drops to 0 at any point, it is considered a loss. This is what the architecture looked like at the beginning of the project. It consisted of a 3-layered approach centered around utilizing the Unity engine runtime as the main container. The application layer contained the higher level systems that support the game experience. The gameplay systems layer is where most of the core project specific functionality lived, and the content and data layer contained the assets and configuration data that supports the gameplay systems. This is now what the architecture looks like in its current state. The core layers from the first demo are still present, but the implementation is now more explicit and further broken out. The application layer handles the player-facing experience just like before. Things like the HUD, pause menu, dungeon map, audio, result UI, and input gating. Under that is the gameplay orchestration layer. This is the main difference that was not in the original design that became much more important as the project grew because the scene controller had to coordinate room construction, geometry, music, final encounters, and floor transitions without every game component owning that life cycle. I did not fully understand the normal architecture of a game system when I first started out, so I didn't realize how necessary it was to differentiate the gameplay orchestration and gameplay system layers so that they could coordinate and process the flow smoothly. The new architecture represents that new understanding. The gameplay systems layer is where most of the core project-specific functionality lives. These systems are designed to be modular so that each major gameplay feature can be developed and tested separately while still integrating into the larger gameplay loop. The content and data layer contains the assets and configuration data that support the gameplay systems. This layer helps separate the actual game content from the logic that uses it, which makes the project easier to modify as new items, rooms, enemies, or assets are added. Overall, the architecture has not changed incredibly drastically throughout the project, and each high-level system represented in the original design still plays its part as expected as shown at the high level. The 4 main non-functional requirements have stayed consistently the same and in mind since their original conception. Modifiability, performance, testability, and usability are the things that I found most important to keeping the project in an ideal shape. Modifiability remained the highest priority because one of the main points of the project was to create a vertical slice base with modular systems that could easily be expanded if needed. The architecture supports that by separating application behavior, orchestration, gameplay systems, and runtime data. New enemies, loot items, traps, room rules, and interface views can be introduced through specialized components without redesigning the entire system. Performance matters because this is a real-time game, so the systems avoid loading a separate Unity scene for every room and instead reconstruct the active room inside a bounded dungeon structure. Testability became one of the most important project qualities as well. Many deterministic rules were managed by the introduction of seeds and authoritative run states. This reduced the level of inconsistency that had to be managed during unit testing because the systems always reproduced the same expected deterministic results when testing a certain seed and scenario. This made testing complex scenarios and avoiding regressions in software very manageable. Usability is supported by presentation systems like the HUD, pause menu, seed display, item prompts, dungeon map, audio feedback, and result overlays. It was important to me to have clear and minimalistic UI components that displayed only the information that was needed, displaying more information in menus or hover interactions to avoid information overload except when the user needed it. The whole of the architecture was shaped by all four of these requirements, and they were all critical for creating clean components and staying on track throughout the project. This system is designed for players who enjoy video games, especially fans of action roguelikes. The roguelike genre has a large and dedicated audience, with successful games such as The Binding of Isaac, Hades, Dead Cells, and Enter the Gungeon, which have showed how procedural generation, randomized runs, and replayable systems can create engaging gameplay experiences. The reason I chose this project is both personal and technical. I've been playing games for most of my life, and I've always been interested in how game systems are designed and built. However, game development like this involves many complex areas, including procedural generation, collision systems, combat logic, any behavior, and player progression. This Capstone project gives me the opportunity to apply the software engineering skills I have developed over a decade to a project that is both technically challenging and personally meaningful. The system will be used as an entertainment-focused vertical slice of a larger game concept. The goal is not to build a fully finished game, but to create a complete and playable gameplay loop with foundational systems in place. By designing these systems in a modular way, the project is hoping to demonstrate a working concept while also leaving room for easy future expansion into a larger and more complete game. For Sprint 3, this is how the remaining planned functionality was translated into actual backlog work. After Sprint 2, the project had a strong foundation. The player could start a run, move, attack, collect basic items, view HUD information, and navigate generated rooms. However, the full MVP gameplay loop was not yet complete. The remaining requirements still included room content, any behavior, loot distribution, locked chests, trap hazards, and a final encounter that could properly end the run. The main goal of Sprint 3 was to complete those remaining systems and close out the core MVP flow. I translated those gaps into specific JIRA stories based on the requirements that were still incomplete at the start of Sprint 3. Locked chests and item rewards became CK20. Room and enemy rewards rules became CK19. Enemy spawning and AI became CK18. Trap hazards became CK15. Final room completion and run ending logic became CK22. The procedural generation work was also formalized through CK34 as the significant algorithmic component report. The prioritization was more nuanced than simply choosing the most exciting features first. I used requirement coverage, code integration, context from earlier work, and demo value as the main planning factors when assigning story points and organizing the sprint. There was no strict priority order for most Sprint 3 stories. They could generally be worked on in any sequence. The main exceptions were the algorithmic component report, which was tied directly to the Week 9 requirement, and the final room completion story, which depended on most enemy functionality already being in place. By the end of Sprint 3, all required MVP functionality had been completed, meaning there were no mandatory code implementations left. This is also why some stretch goals were pushed out of Sprint 3. The sprint was primarily focused on completing the required MVP loop. Once that was finished, Sprint 4 could focus more safely on polish and optional enhancements such as additional items, seeded run improvements, the hard mode second floor, and the dungeon map. These features were considered non-essential and could be deprioritized if needed in favor of final documentation and demo preparation. These are the main things that were accomplished in Sprint 3. The main focus was implementing the remaining mandatory gameplay systems. Locked chests became functional, so keys now matter as part of the reward loop. Loot distribution became tied to rooms and enemy defeats. Enemy AI was completed with two different enemy types, zombies that walk and shoot at the player, and spiders that jump diagonally and use bouncy projectiles. Trap rooms were implemented with spike traps and wall projectile traps, giving the game challenge outside of standard combat rooms. The final room was also completed as a 3-wave encounter. At this point, all mandatory MVP requirements were covered at an essential level. Sprint 3 also included the significant algorithmic component report, where procedural dungeon generation was formally documented as the algorithmic centerpiece of the project. The work in Sprint 3 was originally slated to be 10 points of work, but after the algorithmic report was added in, As 1 point story, it went up to 11. All 11 of the points were completed and closed out successfully during the time frame. Sprint 4 was focused on stretch features and final deliverables. The expanded item system made the game more interesting by adding a larger item pool, rarities, new player projectile stats, projectile bounces, projectile size changes, projectile speed, and item flavor text. I also added custom and random seeds, which allow a run to be reproduced later. The largest progression feature was the second hard mode floor. After clearing floor 1, a portal opens in the final room, and the player can enter floor 2 with the same build but harder enemies. The final stretch feature was the dungeon map. The map shows the generated room layout, valid connections, current room, visited rooms, hidden undiscovered rooms, chest indicators, and discovered final room information. Sprint 4 had closed out of the testing report, requirement specifications, architecture and design documentation, end user manual, and demo preparation. Sprint 4 was originally planned for 11 story points, although some work was reprioritized, moved around during the sprint. The final scope remained 11 points, and all planned work was completed successfully. By the final build, all 11 use cases and 19 formal functional requirements have coverage through the implementation and testing artifacts. Sprint 1 and Sprint 2 created the foundational elements of the project. Sprint 3 completed the missing mandatory systems, and Sprint 4 then improved the product with stretch functionality. The formal testing report now uses 42 automated acceptance-oriented UATs and 18 manual gameplay tests. The most important point is that by this final demo, the requirements are no longer just planned or partially implemented. They map to visible gameplay behavior, source code commits, test cases, and final documentation artifacts. The algorithmic component is the seeded procedural dungeon generation system. It is responsible for taking a seed and turning it into playable room graphs. It creates the bounded 4x4 layout, stores rooms as nodes, connects adjacent rooms through bidirectional edges, assigns rune types, and validates that the result is actually traversable. The implementation is directly tied to 7 user stories and 6 functional requirements, as it has a large impact across the whole entire system. The key caveat is that the algorithm is not only connected to one story. CK13 is the direct algorithm story because it creates the randomized connected dungeon layout. CK14 builds on that by assigning room types and allowing transitions. Then stories like trap rooms, room loot, final room behavior, the second floor, and the dungeon map all depend on the generated structures. So this is a good algorithm component because it sits underneath several gameplay features rather than being a small isolated calculation. The dungeon is a graph, not just a picture of rooms. Each room is a node of an X and a Y coordinate, and each doorway is an edge between adjacent nodes. The adjacency rule uses Manhattan distance equal to 1, which means rooms only connect north, south, east, or west. The same Manhattan distance idea is used again for final room placement. The final room has to be at least 3 grid spaces from the starter room. With a starter at 0, 0, the cells close to the starter are rejected, and far cells become valid final room candidates. That keeps the run from ending immediately after one transition. The enemy versus trap decision uses a seeded modulo rule. Each grid position becomes a room index using y times width plus x. The seed creates a trap offset, and the room becomes a trap if the adjusted index is divisible by 5. Otherwise, it becomes an enemy room. This makes it so that roughly 20% of the rooms that could be trap or enemy rooms are assigned as trap rooms. Starter and final rooms are assigned first, so they always override the trap rule. This creates deterministic variation without making the dungeon unpredictable or difficult to test. This is how the algorithm works from start to finish. The run begins with either a generated seed or a custom seed. The layout generator receives the width, height, and seed and creates the 16 room data objects. It then connects cardinal neighbors, assigns room types, validates connectivity, and returns a dungeon layout. After generation, the runtime system consumes that result. The game run state owns the active dungeon. The dungeon room navigator determines which room is active and refuses invalid movement. The gameplay scene controller then uses the current room to build the visible environment, doors, enemies, trap, loot, chests, and final encounter content. Later Sprint 4 work also uses the same data for the dungeon map, which is important because the map is not a second version of the dungeon. It is a projection of the generated dungeon state in its current form. From a testing standpoint, the main advantage is that most of the algorithm is deterministic and data-driven. Fixed seeds can validate room types, connectivity, bidirectional doors, navigator movement, final placement, and map grid positions. That makes the ACO both a gameplay feature and a testable software engineering component, which makes it very important. The testing methodology has been refined since the past few sprints. Earlier in the project, I was mixing some manual validation in the UAT section. After feedback, the final testing report separates automated UATs from manual gameplay tests. The traceability matrix maps every selected automated UAT to a use case, formal requirement, user story, and architecture element, implementation, commit, test commit, status, and comment. The test case specification then documents the preconditions, inputs, numbered execution steps, and expected output for each selected UAT. Automated tests focus on deterministic behavior that can be validated repeatedly, such as dungeon generation, room navigation, combat rules, loot selection, item effects, trap timing, and run state. Manual tests cover behavior that is better validated through actual play, such as visual layout, audio feedback, complete scene interaction, and overall feel. The final suite includes 270 automated tests, 42 selected UATs that are from the automated tests, 18 manual tests, and 86.5% line coverage. Every user acceptance test is intended to have a one-to-one relationship with a unit test. Each UAT tries to represent a critical behavior that the system must support, and the matching unit test is the automated proof that the behavior works. This includes critical areas across all of the core gameplay systems. During the development of Sprint 3, I added over 100 new automated unit test cases, and in Sprint 4, an additional 70 were added on top of that. Each JIRA story had its own dedicated tasking section dedicated to implementing new UATs and ensuring that the code coverage stayed comfortably above the 70% line coverage goal that I had set. This resulted in a large amount of tests being added as the code base became more complex and filled out. These are some examples of tests that are especially important to the integrity of the project that were added or updated recently. UAT 10, Stat Modifiers Update Player Stats, protects item effects and player stats. If it fails, items may still appear in the game, but stop actually changing the player. UAT 29, Generated Rooms Are Connected, protects the procedural dungeon system. If it fails, the game could generate rooms that the player cannot reach, which would break the core roguelike structure. UAT 26 is a good example of how testing evolved late in the project. It originally validated projectile collision and damage, but a Sprint 4 bug showed that a projectile could potentially damage multiple overlapping enemies during one physics frame. The updated UAT now verifies that a projectile is consumed immediately after its first valid hit. I would also call out UAT 37 and UAT 42 because they protect the new Floor 2 run completion behavior in the dungeon map's use of authoritative grid positions. During the demo portion of the testing showcase, I will show an example of how a functional requirement leads to a UAT's creation, all the way to the implementation and execution of the test within the Unity editor. The asset pipeline remained a major part of the project. Since this is a solo capstone and I am not an artist, AI-assisted asset creation made a very large difference. Almost all of the visual assets were generated or refined through GPT image workflows, including sprites, animations, item icons, and environmental pieces. For music, I used Suno AI to create the main music theme, dungeon exploration music, boss fight music, and supporting sound variations. The main menu and settings menu were also supported by the Bloodlines Dark UI asset pack. This is a free asset pack that I found online, so it is technically just open source. One of the big lessons is that asset generation saves time, but it does not make Unity integration automatic. I still had to handle transparency cleanup, sprite splicing, import settings, sizing, sorting order, animation setup, audio loop setting, and testing, and runtime integration. This pipeline made the final product look much closer to what I intended from the beginning with my vision than placeholder art would have. For the first part of the demo, I'm going to walk through the full life cycle of how the project's use cases and requirements are translated into UATs that are ultimately implemented and run as automated tests. We'll start here in the software architecture and design document and take a quick look at the functional requirements and use cases. As discussed earlier, the MVP defines 19 functional requirements and 11 use cases. If we scroll down to the use cases, right here, We can see that each one includes details about how it is defined and which requirements it supports. For this example, we're going to look for use case 6, collect item or key. This use case is related to SR10, SR14, SR15, SR16, and SR18. So keep those in mind because they will come into play shortly. If we scroll back up to the functional requirements, we can see that each requirement includes a statement describing how the system should behave, along with related acceptance criteria. Since UC06 is connected to SR10, SR14, SR15, SR16, and SR18, we can look at SR15 as a good example because it is particularly relevant to item functionality. At this point, we've established the relationship between UC06 and SR15. Now, if we move over to the software testing report and scroll down to the test traceability matrix, we can see that how each relationship is carried into testing. So here we have our test traceability matrix, and the test traceability matrix contains information about the use cases being tested, the related function requirements, the implementation and test commits associated with the work, and a test comment that explains the automated test and its role in verifying the requirements. If we scroll further down, we can also see the test case specifications, and each UAT ID here links directly back to the test traceability matrix and contains information about the test inputs, execution steps, and expected output. There is also a separate manual testing section. These tests are primarily used to verify visual behavior, gameplay integration, and regression issues that are difficult to validate through automation. They do not have the same level of direct architectural traceability as the UATs in the test traceability matrix, but they are good for verifying things visually and regression based. Now, if we go back to the matrix that we were originally looking at, and remember that we are looking at use case 06 and software requirement 15, we can find tests that are directly validating those items. Right here we have UAT 14. It links use case 6 as a use case, and it links SR 15 as a functional requirement. So I think we can use this as our example. And if we click the commit here, we can actually see the commit that it was introduced and implementation and the implementation and how it's related to the actual automated test and the code based. So this was committed on June 19th, and this commit in the repo. And if we move over to the test comment, the first line is always the name of the automated test that it's related to. So collector applies item benefits to run is the name of the automated test, and its purpose is to verify that collecting an item correctly applies the item's benefit to the current run. If we scroll down to UAT 14 in the test case specification, should be right here. Yep. We can see that the inputs used by the test, the execution steps that apply to the item to the player, and the expected results that the appropriate player stats are updated based on the item's effects. The process does not end with this documentation, though. These tests are defined as part of the development cycle and then implemented as real automated tests in the test suite so that they can continuously verify the software. So if we go now and we switch over to the Unity editor, we can actually now run those tests directly. From here, I can open the test runner and go to analysis, code coverage, and this actually opens up the code coverage tools that we use and the test runner itself within the Unity editor. And you can see here that we have 270 tests, and if we click run all, we see that they all run. The test suite currently takes about a second to run, and then the rest of the time is actually the code coverage report fully generating in the background. And I use this process as almost like a pre-merge pipeline. Before committing major changes to the main branch, I always run the full suite to make sure that existing functionality has not been broken and I'm not introducing any issues into the main branch. And so if we expand the test groups here, we can actually see that under the edit mode, there's a bunch of different folders that are grouped by what system it's related to. Since the test that we were looking at was related to items and loot, and testing their functionality, I'm going to guess that it's under the loot tests. And here it is. So what we were originally looking at in the test traceability matrix was the collector applies item benefits to run. We can see that the test passed, and all of the other tests around it, all 270 also pass. That is essentially the full life cycle of a UAT from its original use case and functional requirement through the traceability and test specification documentation as well, and finally into a executable automated test. All 42 formal UATs follow the same general process, and they have been very useful for identifying regressions as the project has evolved. Now, if we quickly move over to the code coverage report, the project is currently at 86.5% line coverage approximately. I like to expand the report by module so I can actually see how well each individual area of the project is covered. The code coverage has been a useful metric for identifying areas that may need more testing, but it's important to remember that coverage by itself does not measure the quality of the tests exactly. It mainly tells me how much of the code is being exercised, not necessarily how well that behavior is being validated. That is up to me to write good tests, not just a bunch of tests. So yeah, we can see the line coverage for each individual module and system and how well it's tested. And we have 92.2% method coverage, 86.4% line coverage. Almost the whole entire repo is covered with the 270 tests that we have here, and of course 42 of those are the UATs, which are the most critical functionality. I would say that wraps up the testing portion of the live demo, and next I'll move into a quick overview of what we're going to see before launching the live gameplay demo. Before the live gameplay demo, I have a couple of different visuals to go through to kind of show you what to expect when we actually get to showing off the game and get you familiar with what you're going to see. So here you see a grid of a 4x4 with a bunch of question marks. This is going to be what the dungeon map looks like, and it is essentially a representation or a projection of what the current dungeon state looks like. Those question marks are going to get uncovered as we traverse throughout the rooms, and eventually we will find the final room where we will fight the waves of enemies. And then once we fight those waves of enemies, you're going to see a portal appear. The portal is the sprite that you see up top there. That's the full sprite sheet. And if we walk up to that portal and enter it, we're going to enter the hard mode version of the game, which is the floor 2. So before, it used to be that you would finish the waves and then you would complete the game. I thought that it didn't have enough to it. I wanted a little bit more and something that represented the roguelike genre a little bit more. So now you enter a portal and you go to the second floor and you kind of do it all over again, but you face harder enemies. You get to use your items from the first floor. You get a full heal. Yeah, so if we move on. So we have 2 enemies here, and these are the 2 enemies that you're going to see throughout the dungeon. We have the zombie. The zombie will run at you and try to shoot a projectile at you every couple of seconds on an interval. And then we have the spider, And the spider is a little bit unique. I wanted the enemies not to be too similar. So the spider's gimmick is that it will jump diagonally and that it will shoot diagonally at the player. So not necessarily directly at the player, but in their diagonal direction. And another thing about the spider is that the projectile that they shoot bounces once off the walls and can hit you after it bounces. Um, so you'll see about like 5 to 6 of these in a normal room, or 2 to 3 of them in a trap room. And they are the main enemies that you're going to encounter. They are the main threat that you are facing, and most likely to kill you throughout the game. And lastly, we have the items. At the top there, we have the chest sprite. That is just another way to get items using keys, and they have a higher chance to drop higher rarity items. So currently in the game, there's common, uncommon, rare, and legendary items. The items that you see here are the additions to the game. So there was originally 4 items to the game that were pretty basic, and then after I did the stretch goal to enhance the item feature, that's when I added rarity and these selection of items along with a bunch of different more projectile stats. So as I go out through the run, kill monsters, open chests, find random loot, you'll see these items pop out throughout, and I'll open up the pause menu and mouse over them so that you can see what their stats do. But this is 21 out of the 25 existing items in the game, so it is the majority. And real quick, before we actually get into the gameplay, I wanted to show this diagram that I made for the software end user documentation. I think that it's pretty useful for laying out for somebody that's new to the game or doesn't play many video games what to actually do and how to interact with the game with a keyboard and mouse. So obviously you have your movement, which is WASD. You attack by putting your mouse or somewhere on the screen and then clicking, and then whichever direction you're facing with your mouse is where you will shoot. You interact with items, chests, portals. With E, you can pause or resume with escape to bring up the pause menu. Use left click to go through the menu selections and other things like attacking, like I said before. The dungeon map can be brought up with M and closed with M. And yeah, so let's get into the actual gameplay. So now we are in the game. Welcome to the main menu. If you watch the first demo, you will know that this looks pretty similar. I'm going to try to go through all of the functionality in the game, whether that takes 1 or 2 runs. Hopefully I don't die too many times or embarrass myself. But just to go through, the continue button is still not implemented. It was a stretch goal that was never able to be accomplished, so unfortunately that button is going to stay as a pop-up that says that it's unimplemented. The settings menu is the same as before. We have sound settings where each one increases and reduces the sound. I'm going to keep it pretty moderate. And then if we click New Run, we can now see a new pop-up that is a stretch goal that we added. This allows us to enter in custom seeds to make sure that if we like a run seed that we had, we can reproduce that and test the same run over and over again. I'm going to just enter a random seed, so I'm going to do that, and then we're going to start with that. So you can see the seed in the top right. And before, you used to start with a chest and a key that would open an item. I removed that because chests now give higher rarity items. So we're going to go up and pick up this monster heart right here. You can see that it's a common item, and it just gives +1 max heart. you can see the current stats that we have right here. So we have damage 1, movement speed 5, attack speed 1, projectiles 1, projectile speed 8, projectile bounces 0, and projectile size 100%. These are all of the default values that you have. The monster heart doesn't affect those because it only affects hearts, so you can see your hearts up here. We also have 0 keys to start out. And then we have a dungeon map up here. So you saw that in the slides. And you'll see that this actually uncovers different icons depending on what floors we go in. It will show chests if we have an unopened chest in a room. And you can expand it by pressing M. So if you prefer to see where you're going and what's going on in your dungeon, you can have this up as an overlay, or you can just minimize it again by pressing M. So I guess we can start exploring. The final room is always trying to get as far away as possible. So it's not going to be one of the first things that we encounter. It should be at least 3 rooms away. You can see this is just a regular enemy room. We have enemies and spiders here. Oh, and it looks like one of them dropped a key. I think that's about an 8% chance for any random item to just drop an item. And you can see now on the map that now we entered a room. The icon that was a question mark is now replaced with a knife icon. This is actually the knife item, the bloody knife item. That's just been repurposed as a UI component. So let's continue on. We now have a key, so we want to find a chest. Oh, got hit by the spider there. So the spiders and the zombies on the first floor both do half a heart of damage. Ooh, we got another item. So if we open up the pause menu here, we can see that Boo Beans is a uncommon item. That's what the green represents. And the label promises courage. The rattling suggests otherwise. And this gives +2 movement speed and -25% projectile speed. Projectile size, sorry. So you can see now that our current stats, our movement speed was 5 before, and our projectile size was 100%. You're going to see a lot of items that have positive and negative trade-offs. The higher tier generally have more positives than negatives, and they tend to be more powerful. So you can see now that in-game, I am quite a bit faster. My movement speed going from 5 to 7 gave me something like a 30% increase. So I'm quite a bit faster now, and I should be able to avoid the enemies now. Going to continue through the rooms. Looks like we have a chest here in this room. And after we clear out the room, we're just going to open that up. See what item we get. Hopefully we get like a rarer one. Oh, we got Boo Beans again. That's pretty funny. So the items actually stack when you get most of them. So now you can see that there's a ×2, or just saying that you have 2 of the item. So now we have 4 movement speed and -50% projectile size. So we have really small projectiles and we're really fast. I'm just going to continue on now. Oh, we have another key here. So I'm just going to clear these out. Hopefully we can get some items that are up our damage, because currently we have no damage and we're not doing much here. Oh, it looks like we actually found the boss room. So the boss room is a little bit unique in that it has an icon on top of it with a skull to let you know that the boss room is there. And also, on the mini map, I made it so that the boss room shows as a skull when you enter a room that is adjacent to it, so that you don't have to actually enter it in order to have it marked on your map. I did that because usually when people find the boss room, they probably don't want to explore it immediately. They probably want to try to get stronger before they go back to it, so that was a deliberate design decision. Now that we find the boss room, I think we want to explore the rest of the rooms. We want to see all that we have to offer in this layout, and we want to get some more items so that we can kind of show off the item system a little bit more. So you can see here now that the zombies are walking at you, and then every like 1 or 2 seconds they shoot a red projectile at you. the spiders, they jump diagonally and then they shoot a diagonal projectile. Like I said before, they don't actually shoot directly at you. They shoot diagonally, so you can actually just kind of game their AI if you'd want to. Um, I thought this was a cool thing to leave in. Oh, okay. We have a trap room here, and the trap room is unique in that it has projectiles that shoot from the walls, and it also has a couple enemies to keep the pressure on. So you can see here, I'll explain it more after I pick up this item. So you have floor traps here. The floor traps, oh, I just walked on it by accident. They do half a heart of damage, and they hurt you every 1 second that you stand on them. And then there is these wall shooters that are randomly assigned in fixed positions, and they shoot projectiles across the floor on an interval, and they also do a half heart of damage. So I'm gonna get out of here now before I die to the traps. But what is that item that we got? We got the chili pepper. So this is another common item, and it gives me +2 attack speed. It's technically more damage since we're now attacking faster. But we are 1 health now. I've distracted myself by talking so much. So we're gonna clear this room. We're gonna open this chest. We got another boo beans. That is a little bit insane, actually. There's I think there's 4 common items. There's 9 uncommon, and there's 9 rare, and there's 3 legendaries. So with 9 uncommon items, getting 3 of the same type is pretty lucky or unlucky, depending on how you look at it. All rare, uncommon, common, and legendary items all have the same drop chance. It rolls for the rarity first, and then the item. So we have 3 boo beans and 3 peppers, so we're attacking really fast and we move really fast. But we're not doing much else here. I would like to get some more health items so I don't accidentally die. So I'm going to try to finish up this floor, and then we can do the boss room so that we can kind of show off a little bit more. I believe the spiders have 3 health and the zombies have 5 health on the first floor. So with one damage as your base, it does take 3 to 5 hits to kill them. 1 damage will increase our kill time significantly. So we got some more health, and we got a treasure map. So we now have another health added to our pool, and we got a treasure map. So this gives us even more movement speed and projectile speed. So we are quite speedy. I hope we don't get any more movement speed, or it's going to be quite insane, honestly. Alright, so we have our last room here before we get to the boss room. Try not to get hit anymore, just so that we don't have to do a whole nother run. There we go. It's nice. We got even more health. Alright, so for now, because I did not get the chance to implement the full boss feature that I wanted as a stretch goal, the final encounter is just waves of enemies. For the first floor, it's just zombies, and it increases the amount a little bit every wave, and then once you kill these zombies, the portal spawns. On the second floor, you'll notice that the enemies change. They have a redder tint, and they're a lot harder to kill. They have about double the health, and they have increased stats and new abilities. And on the final waves of the second floor, you see spiders and zombies. Oh, nice. We got some more health. We were at 1 health, and now we're at 4 because we just found a bunch of hearts. I'm just gonna keep running around the room. I'm so fast that if I just run in circles, I don't think there's any chance that these zombies can do anything to me in their current state. So I'm just gonna keep with that strategy for now. And you see now that as the enemies die in the final wave, that the music fades out and the portal spawns. When you walk up to it, you hear a sound effect and a prompt telling you to go to floor 2. So if we click E, now we're on floor 2. So if you look at the dungeon map, and I'm going to expand it here, we will. They're all question marks again. So now we got to explore all over again. You can actually see that we healed to full health. So getting all of these monster hearts actually benefited us pretty good, because all of that health that we lost is now gone. And now if we go into one of these rooms, we're going to see that the enemies are quite strong. You see now that they're a lot faster, and the spiders shoot 2 projectiles that bounce once. So I'm going to keep with my strategy for now of trying to kite them around in a circle. But because they shoot 2 projectiles and they bounce still, it is quite hard. I'm getting a lot of key drops. It's a good thing that we found a chest in here, because I'm going to need a lot of chests. Ooh, spinach. Okay, spinach is damage, so that pretty much just like doubled our damage. I'm going to try to take out the spider first, because they do a lot more damage if you let them go untouched. So I'm just going to try to go through these floors and take as little damage as possible. We have a trap room here. Trap rooms appear about 20% of the time, based on the dungeon generation formula. And this is actually very hard to deal with these traps here. Alright, we did that. Nice, we got ourselves a chest in here, so I'm going to try to get that without taking too much damage. Our projectile size is also really small from our item modifiers, so we kind of have to aim very well. Our shots are so tiny. Alright, we got a forgotten skull here. This is -1 projectile speed and +1 projectile bounce. So projectile bounce will help us out. Ooh, and we got a bloody knife. So you might notice that the bloody knife is actually the same icon as this, because it's reused, and I just modified it slightly. Bloody knife is our first rare item, and this is +2 damage and -3 attack speed. So we now have quite a lot of damage. And we're just going to try to avoid the traps here. Ooh, and we got a garlic, and I'm taking damage from the traps. This is +2 max hearts and -0.5 movement speed. You won't notice the movement speed too much, just because we already have so much. So now we have a good amount of damage, and we have some projectile bounce, we have some damage, we have movement speed. We did have a lot of hearts until I lost them all. Ooh, bottle lightning is more movement speed. Oh, we found the boss room, but I don't want to enter that yet. I'm going to try to clear out this whole entire dungeon without dying. We got ourselves a new item. We got ourselves a brine brain. This gives us less movement speed again, +2 attack speed, and +1 projectile bounce. I think we have 2 projectile bounces once, so now you're going to see these bounce quite a bit around the room. And yeah, I wasn't entirely happy with the difficulty of the first floor. I wanted it to be approachable for someone new to the game, so I made it quite easy. But I also didn't want the game to be too easy. Ooh, another bloody knife. So now we have even more damage. So my design proposition was that I make the first floor pretty approachable, and then after that, I make it so that the second floor is a little bit harder, but since you'll have some items to accommodate you, you'll be able to kind of handle it better, and it'll feel a little bit better when you actually win, because it is harder. You can see that even though I made the game, I'm struggling quite a bit on the second floor. We actually got a new item here I want to go over. So we got Dead Man's Coin. It's more damage, less movement speed again, and more projectile speed. So we are now have enough damage that we can one-shot the hard mode spiders, and I think we can two-shot the hard mode zombies, so we are quite strong at this point. Oh, I actually didn't show this off yet, but the items do stay if you leave them in the room and you come back. And if you have a key or you don't have a key and you see a chest but you're not able to open it, I made it so that the dungeon map lets you know that there's a chest in the rooms, so that if you happen to find a key in another room, you can go back here and open this. Fortunately, I don't have any, but yeah. So final room here before. Oh my god! I just killed myself. Okay. Well, I'm going to start another run and then get it back up to the point where I am at the final hard mode boss, and then we will go from there. Okay, we are back with another run after we died. I obviously died on purpose just to show the defeat mechanic of the game. But anyways, we have cleared through most of the rooms. We have another build going here with completely different items and a random seed. Two new items that we have here that I don't think we saw before were the Watcher's Eye, which gives a lot of minus movement speed, and then projectile speed, projectile bounce, and 100% projectile size, so you get some big shots. Blood Chalice, which gives some max hearts, damage, and minus movement speed. I actually think the other build was stronger before, but yeah, let's do the final room. So you can see now that the final room for hard mode, ooh, we got some items here, can actually spawn spiders now. So that's something that can't happen in the first floor. So we're going through, now we're on the final wave. This key is kind of pointless in the last room. But yeah, here we are, we're about to finish the game. You can see that immediately after you clear the final enemy, you get this pop-up that says victory, thanks for playing, and then you can return to the menu. And you can play another game. So you can start up as many games as you want. Every game's going to be different as long as you use a different seed. I'll now begin the closeout and talk about some overviews for the sprints and project as a whole. For Sprint 3, the burn down chart shows steady progress. I committed 6 times during the sprint from July 6th to July 28th, which shows consistent development activity at about 2 commits per week. By the end of the sprint, all work was completed despite adding an additional point due to the algorithmic component documentation. Overall, the sprint velocity exceeded the original plan while still keeping the project aligned. For Sprint 4, the burn down chart looks a little bit rougher visually. I committed 3 times during the sprint from July 28th to August 16th, which accounts for once per stretch goal implemented. The reason that the graph is so all over the place is due to the sprint refactor that was implemented to reprioritize which stretch goals would be most beneficial to the project at the beginning of Sprint 4. This combined with the fact that the final documentation user story was open for all 3 weeks of the sprint are the reason for the visual. By the end of the sprint, all work was completed despite how it looked though, and I was able to implement all of the stretch goals that I had wanted to in order to enhance the project. This slide summarizes the workload and velocity across the whole project. Sprint 1 was planned for 9.5 story points and completed 11.5. Sprint 2 was planned for 10 points and completed 13, which reflected strong progress but also some additional work related to UI and demo preparation. Based on that, I adjusted the later sprint capacity to 11 points to account for the fact that I was overperforming. Sprint 3 completed the remaining mandatory MVP features, and Sprint 4 completed the stretch work and final deliverables. Across all 4 sprints, the project completed about 46.5 story points, with each point estimated being around 7 to 8 hours of work. Each sprint had roughly 80 hours tracked against it, which was very close to the capacity that I had set. The main lesson is that the amount of raw feature work was only part of the equation. Documentation, testing, traceability, demo preparation, asset integration, and final polish took a significant amount of time and had to be treated as real work that was not properly considered at the beginning of the project. This project review is going to cover the whole development lifecycle and how Crypt moved from a concept, functioning prototype into a finished MVP. In Sprint 1, after completing the architecture and requirements documentation, the main goal was to prove that the project foundation worked. I set up the Unity project, created the main menu and new run flow, implemented player movement and attacks, added the first HUD elements, and created the runtime stats and game data model. I also pulled in the early loot configuration work once the foundation was stable. That is why Sprint 1 finished above the original 9.5 point plan at 11.5 completed points. The testing evidence also started in Sprint 1. The first UATs and unit tests were focused on the most basic requirements: starting a run, moving, colliding with boundaries, showing HUD information, and tracking health. These were not the final testing artifacts, but they created the traceability pattern that later became the formal testing report. At this point of the project, the testing was not well defined. I had 19 UATs within my test traceability matrix, but my execution flows written here were not the best they could be, and I still had manual tests mixed in with the current UATs. For code coverage, I had a late start on establishing it, so I had to set the line coverage to 70% as a goal and accomplish as much as I could within short progress, which was around the 60% range. Sprint 2 is where the project began to look like the intended roguelike loop. Items became usable in-game, the pause menu displayed real run information, the dungeon generator created a seated 4x4 room grid, and the player could transition between generated rooms. Sprint 2 also included the UI overhaul, demo preparation, and the first major code coverage push. The coverage goal was 70% for core functionality, and this sprint exceeded that target at around 79%. The UATs at the end of Sprint 2 were at 35, but I still had not decoupled this manual testing from it, so it was bloated. At this point, over half the functional requirements were completely satisfied, with another 40% being partially completed by the testing and implementations of the project. The second half of the project is where the remaining envisioned MVP functionality was translated into specific backlog work. At the start of Sprint 3, the game had a solid foundation, but the full gameplay loop still needed chests, room, and enemy loot distribution, real enemy behavior, trap hazards, and a final encounter. Those gaps became the Sprint 3 stories for locked chests, loot distribution, enemy spawning and AI, trap rooms, final room completion, and the algorithmic component report. Sprint 3 is important because it completed the mandatory MVP. Locked chests now spent keys and generate item rewards, enemy rooms and room clear events can distribute loot, zombies walk and shoot while spiders jump diagonally and use different projectile behavior, trap rooms contain spike and wall projectile hazards, the final room runs 3 waves and produces victory or defeat outcomes, and procedural generation was also documented as the significant algorithmic component because it controls the seated 4x4 graph, room connections, room type assignments, and final room placement. Testing expanded in the same direction as the implementation. Across Sprint 3, I added 13 automated UATs and 7 manual tests tied to loot, chests, enemy AI, traps, and the final encounter. This mattered because these were the systems most likely to break the complete loop if they failed. I also was able to put in the work by the end of the sprint to completely separate the manual tests from the UATs in their own section, so that it no longer inflated the UAT number. The final count at this point that verified all use cases and functional requirements was 40 UATs and 17 manual tests. Sprint 4 then shifted from mandatory feature completion into final polish and stretch depth. I expanded the item pool with 21 additional items, added rarity tiers, and added projectile stats such as count, speed, bounce, and size. I added custom and random seeds, a second hard mode dungeon floor through a portal, and a dungeon map that tracks room positions, current room, visitor rooms, connections, icons, and chests. I also completed the 4 final documentation reports. By the end, the testing report selected 42 formal automated UATs and 18 manual gameplay tests from a broader automated suite of about 270 tests. With final line coverage sitting at 86.5%, it was quite impressive. Most of the effort in testing during this time went into updating and validating the existing UATs against any updates needed by the stretch goals, so there was not a ton of new tests, mostly just updates. That's a total overview of the start to finish of the project. It certainly was a mouthful. To close out, this project taught me a lot about building a game as a software engineer in Capstone. On the technical side, I learned that Unity UI and asset integration can take much more time than already expected, even when the core logic is already working. I also learned that physics-based defects often need both automated and manual validation. Deterministic tests were extremely useful for systems like procedural generation, loot, trap timing, and run state. On the project management side, I learned that documentation, reporting, and demo preparation need to be treated as real backlog work. I'm not used to doing Scrum Master or product owner type work, so I was only really thinking of it from a developer perspective at that point. I'm glad that I allocated time for them in later sprints, because the final weeks would still have been much harder without that. I would still like to expand Crypt Night further with more enemies, a unique boss, and more content, but I'm happy with the final Capstone result. The project ends with a complete playable loop, meaningful stretch features, final documentation, and a test suite that protects the core behavior. Thank you for watching the final Crypt Night product demo.